Dear students, welcome to the DSP 6th class on. So in the last class we studied about the basic operations performed on the signals. In that what you studied? You studied operation performed on dependent variables. In the basic operation on signals, we have to study the two types of the operations, that is, one is basic operations performed on dependent variables and the other one is independent variables. In the last class we completed the operation performed on dependent variables. What are the operations we studied? Addition, multiplication, differentiation and the integration, and another one thing is amplitude scaling. In this way, different types of the operations, what are the performance of these operations on dependent variables you studied. In today's class, we are going to study the operation performed on independent variables. Okay, operation performed on independent variables. There are the three operations are there. They are time scaling, time shifting and the reflection. These three are also very easy. Okay, what are the operations performed on independent variables? Time scaling is the one operation, time shifting and the reflection. First, let us study the time scaling. What do you mean by the time scaling? Okay, first let us take x of t be a one continuous time signal. Then the resultant signal y of t is equal to the multiplying factor with a, that is x of a of t. It is called what? Your time scaling. Let x of t be a continuous time signal. X of t is one continuous time signal. The resultant signal y of t is obtained by scaling an independent variable. That is called the a. Okay, so how you are going to write? Y of t is equal to x a of t. That means any one independent variable that is multiplied by this x of t, then you are going to get the time scaling signal. Okay. So we will see the figures for this time scaling signal. Okay. So first one is what your just one, this one figure is there. It is your rectangular pulse. Just you see, we are studying the time scaling on continuous time signals. In the first class, we studied that if t is there means it is continuous time signal. N, the x of t is nothing but what? Your continuous time signal. X of n is nothing but a discrete time signal. That you have to remember. You see here, this is the t and this is x of t. Here 1 minus, this is your positive, this is your negative. All of you know that. Positive quadrant and the negative quadrant. 1, 2 and this is minus 1 and 2. This is x of t. So this is our simple rectangular pulse. This is our simple rectangular pulse x of t. So we have taken this as a one continuous time signal x of t. Okay. And next what happens? So this is the second figure. In this what happens? The same figure a is there. This figure is compressed by the factor of 2. That means here y of 2, how we have how we get this, the compressed means here we have did the multiplied by 2 we did, but this is called the compressed factor. How you are going to get this, you will just understand. Let us wait. So first you think that if we compress it by the factor 2, the width is decreased. Okay, this is your figure 2. And what is this your figure 3 means? This is your expanded by the factor of 2. Okay, this is your expanded by the factor of 2. Let us see how this happened now. Okay, so in the above figure, what happens? It is the demonstration of the time scaling. Correct? Depends on the time, the shape of the signal is going to change. Okay, this is what your demonstration of time scaling is there. Next, in the next sentence, the answer for this and the answer for this. So here what happens? When your A is greater than 1. Okay, so what is time scaling is nothing but how you are going to get the resultant signal. Y of t is equal to x A of t. Correct? If A is multiplied to this signal, then you are going to get the resultant signal y of t. This y of t is called time scaling signal. Correct? And here, if A value is greater than 1, then y of t is a compressed version of x of t. Okay, if A value is greater than 1. So here A value is 2. So that is why what is our resultant signal is getting, that is a compressed version of the x of t. Okay, so that is why what happens here, it is compressed. Why I have written here compressed by the factor 2? Because I have taken A is equal to 2. So that is why when you are taking A is equal to 2, you are going to get it is 1 by 2 and this is minus 1 by 2. So that is why I have taken this compressed by the factor 2. Similarly, what happens if A is less than 1? So less than 1 means it is half. Okay. So when A is less than 1, then you are going to get y of t is expanded version of x of t. So you are going to get the y of t is expanded version of the x of t. Okay, so that is why x is equal to 1 by, so here directly they have written as t by 2. These figures I have taken from the Ganesh Rao book. Okay, the same thing is there. Okay. So let us hope all of you understood the concept of time scaling. So similarly, what happens for the discrete time signal? This is our discrete time signal. Okay, what do you mean by discrete time signal? Here the strength of the signals are different. Then it is called the discrete time signal. So for this signal, if I apply the time scaling, then what you are going to get? This type you are going to get. When I have taken A is equal to 2, then you are going to get this type of the signal. What happens here? In this, so this minus 1, so the amplitudes of the 1 are missing. Okay, so just you compare and understood what happens to the time scaling signal for this discrete time signal. Comparing figure A and figure B, it is observed that samples of amplitude 1 are totally missing in Y of n. Samples of amplitude 1. These are the amplitude 1, correct? These are all missing in this figure. Okay, so what happens here? Therefore, time scaling of discrete time signal leads to an inherent loss of information. Okay, actually, what do you mean by signal? What is this? This signals is nothing but these are contains the informations. Okay, if after applying, if I am not able to get any one or the two signals, means what happens here? There is a loss of information in the signal. So in the discrete time signal, what happens when you apply the time scaling property? Then we are going to lose the information. Now let us move to the time shifting property. It is a very important and it is very easy also. Time shifting is nothing but what? It is going to shift. The signal is going to shift by some time. That is nothing but what? The time shifting. So here you see, let x of d be a one continuous time signal, replacing this t value by t plus b. What I told here, t is shifting. How much it is shifting? Plus b times. Then resultant signal, what we are getting, no, that is called a time shifted wave. Understood? Okay. So for example, you can say that, so what I am saying, I will reach the college in 10 minutes. But I reached after 15 minutes. Then what happens? 5 minutes is shifting. That 5 minutes is the B, 10 is the T. Okay, that is called, that is even time shifting property in the signal. So here let us take the continuous time t. X of t is one continuous time signal. If t is replaced by t plus b, it results in a time shifted by the signal y of t. Let us see the some figures also. First let us write y of t is nothing but how much you are going to get. Y of t is equal to x into t plus b. Okay, this is the expression for the time shifting. So you see here what happens. Our simple A is there, B and the C. So your simple first x of t. What is going to tell this figure A? Figure A is nothing but it is a one triangular pulse of x of t. Here what happens? Time shifted version of x of t for B is less than 0 and b is greater than 0. So here you see b is less than 0 is nothing but minus 1, greater than 0 is nothing but 1. So just amplitude is also x of t is also equal to 1. So this is our simple signal. So for this signal, how you are going to get this b signal, we will see now. Okay. So here what happens? What I did in the figure B, x of t is translated to right by one time unit. Okay, so what we did, we are translated to right. So that means this is shifted here. Correct? If this is shifted here means this should be shifted here. By how much we have shifted? By only one time unit. If b is less than 0, what happens? If b is less than 0, x of t is shifted by an amount b seconds. Okay, x of t is shifted by an amount b seconds. Okay, here b is less than 0. That means how much? B is equal to minus 1 is there here. When b is minus 1, then what happens? That much amount b is less than and equal to 0. X of t is shifted by an amount b seconds. How much you have taken? That much it is shifted. In the same way you can shift for the minus 2 also, minus 3 and so on. Okay. Similarly, this is what your plus. Here what happens? X of t translated by an a one time unit. If b is less than 0, it is translated to right. When b is greater than 0, it is translated to left. Okay, and that is important here. But how much amount? It depends on the b value. If b is plus 1, it is shifted plus 1. If b is plus 2, it is shifted plus 2. Okay, presently in the figure we showed for only 1. Okay, let us revise the time shifting once again. Okay, what is the time shifting? So this is your simple triangular pulse is there. If we want to shift by right, then your b value should be less than 0. If we want to shift to the left, then your b value should be greater than 0. That is a simple concept is there in the time shifting. Okay, x of t be a one continuous time signal. If t is replaced by t plus b, then it results the shifting signal. So what the shifting signal? Usually in almost all operations we have taken y of t is a one resultant signal. Y of t is equal to how much? That is x into t plus b. Now what is your next one? That is reflection. Reflection is nothing but what? Okay, when the signal is there, if you are applying minus sign to that, then you are going to get the reflection sign. Here you see, let x of t be the continuous time signal. The reflected version of x of t is obtained by changing t with minus t. Okay, if the signal is in positive sign, then if you shift to the negative side, then it is reflection of that. Usually reflection is you are going to get in the opposite direction. So I think they are using that concept and they are telling that if x of t is a one continuous time signal, the reflected version of x of t is obtained by changing t to minus t. So let us write the resultant signal is equal to y of t is equal to x of minus t. The resultant signal is equal to, y of t is equal to x of minus t, represents the reflected version of x of t about the vertical axis. Okay, here you are having the figures. This is your y of t and this is your y of t is equal to x of minus t. This is in positive direction. In a positive quadrant, it comes to the minus t. When you are doing means it is coming to the negative side. So this is figure A is your simple triangular version of x of t and B is a reflected version of the C, and that too about the vertical axis they are telling. That means here we can't put any other in any other directions, you have to put in the vertical direction. So here some important points about this reflected signals. So here what are the important points means, for an even signal x of t, the signal x of t and its reflected signal x of minus t are identical. So if the signals are even, that also we studied even signals and the odd signals. In the even signals, when you are applying the reflected the one property, means what happens, both are the same in the even signal. But happens in the odd signals, both are in opposite direction. For an odd signal x of t, the signal x of t and its reflected signal x of minus t are negative of each other as shown in the below figure. This is our x of t signal. Okay, what happens to x of minus t? This comes this side and this comes this side. This comes this side, this comes this side. Negative to each other. This is for the odd signal. And these are what I am using the books, this all of you. and this is my concern about my students. Please go again this video, students, for the better understanding. If you have any doubts means please put the doubts in the telegram, sorry, in teachment chat box, so that I can answer as early as possible. Okay, meet in the next video.